Hello everyone, welcome to the 15th lecture in this series. In this lecture, we are going to explore more about applications of Stack. Specifically, we are going to focus on three applications, namely balancing parenthesis, infix to postfix conversion, and evaluating a postfix expression. Hope you remember with the previous lecture, we learnt how to use stacks for handling recursion and for addressing the problem of towers of Hanoi. So now we dive into some more applications of the stack. First, let's see what are all the problems where we could use stack. Hope you would remember in one of the earlier lectures I was mentioning that when we run a program, the program is loaded into memory. Not only the program, its associated data is also available in memory. In addition to all these, some portion of memory is reserved for heap, and the purpose of heap is to handle dynamic memory management and to provide space for system stack. And whenever there is a call to a function, stacks will be used underline, and whenever a function call is made, an activation record would be generated and the activation record would be pushed onto a stack, and upon a function return, the activation record would be popped out from the stack. And in the earlier lecture I was telling you some more applications of stack, like in real world problems, especially in all search problems. Whenever we make some advancements in the search space, the whatever advancements we make is already getting stored in a stack. So in case if at one point in the search space we couldn't go further, then at that point we need to backtrack to find some alternative moves which we could make in the search space. So for backtracking purposes, we may have to use a stack. We may have to record all our moves in the stack. And not only that, in browsers also we will be using stacks to keep track of the pages that we are visiting, and also in all the editors, whatever operations we do on an editor will be pushed onto a stack, and that of course helps us when we do an undo operation on those editors. Now we are going to see specifically three applications where stacks are being used, and the first application is with balancing parenthesis. Of course, in any expression we may add parenthesis to it just to enforce some precedence of operations over others. And if in case an expression is left without parenthesis but the expression contains more number of operators, then we know that we have a precedence of operators, and only in that order of precedence every operation has to be evaluated so that we get the right result for the expression. So here in this example you see we have an expression a comma b plus f of 4 star 3 comma d plus f of 5. So here you could see the use of braces, parentheses and square brackets, and here you could see that all the parentheses, be it open or closed, they always occur, they have occurred in pairs. So for every opening there is a corresponding closing parenthesis or bracket or braces. So if this is the way we write our expression, then it means all the brackets and parentheses are matched, and so the expression would be evaluated correctly. And there are some bad examples of using this parentheses or brackets which I have summarized here. So here you could see that there is one opening bracket and of course there are two closing brackets, and you could see here there is an imbalance. And in the second example also you could see there is two open brackets whereas we have only one closing brackets, which means another closing bracket is missing here. So if this is the case, in this case you can imagine some operators and operands in between the brackets, and if in case we miss this brackets, then the precedence or the priority of the operation could not be resolved correctly, and thereby we will be encountering errors when we attempt to evaluate such expressions. And in the last example also you could see there is the right for every opening we have a corresponding closing, but the order in which those brackets appear is not the way we expect. So, there is a mismatch in the order of the brackets. So, these are some of the bad examples. Now, we are going to see how we are going to check whether the parentheses or brackets available in an expression is balanced or not with the help of a stack. So, parenthesis checker is actually a program which checks whether the parenthesis in a mathematical expression is balanced or not. So, here we may, by parenthesis we actually look into three sets of symbols. It could be a parenthesis, it could be braces, or it could be brackets. So, for every expression we have, I mean the input expression, we will be verifying that for every left parenthesis, braces or bracket, we do have an associated right parenthesis, bracket or braces. So, if that is the case, then we will say that the expression is balanced. So, here I have summarized some of the valid usage of parenthesis, brackets and braces, and you could see on the left side where I have given the right mix of or right pass of parentheses and brackets. So, you could have any number of parentheses, brackets or braces in an expression, provided that whenever we have a corresponding opening and the same closing should be present. So, here you could see that with this example we have a bracket that becomes the first one. So, in this case the closing bracket should be the last one here, and whenever we have a square bracket, here we have two sets of square brackets, and you could see that there is proper closing of square bracket for every opening bracket. So, this is the way it should be, and I have listed some of the invalid usages of these brackets and braces and parentheses. So, this is the procedure which we use in order to decide whether the brackets in the expression is balanced or not. So, here in order to start with, we should have a stack first. We should have a stack declared first, so that a stack could be implemented either using arrays or using linked list. It is according to our preference. And to start with, the stack should be empty, and we will be reading every character from the expression, and if suppose from the expression the character read is a open bracket or a open braces or open parenthesis, then we will be pushing on to the stack. So, if it is a open symbol, we will be pushing on to the stack, and if in case we encounter a closed bracket in the input expression, then we may have to pop an entry from the stack, and we have to check whether the popped element or the popped bracket is the closing one of the corresponding opening symbol. If they both match, then we can successfully proceed with evaluating the next set of inputs from the symbols from the input. If not, then we have to report an error, and if suppose what we have read is a non bracket symbol, then we can very well skip the character that is being read from the input expression. So, here we have an example. We have the open braces first. So, it has to be pushed on to the stack. Next is a character. So, it is an alphabet. So, we just ignore. So, here the purpose of this program is to read the symbols from the input expression. Only if it is bracket we need to do some action, otherwise we can ignore and proceed with reading rest of the symbols in the input expression. So, next is a comma. So, we ignore that. Then we encounter a open bracket. So, since it is a open symbol, we have to push it onto the stack, and then we will be ignoring B plus and F, and then we encounter a square bracket. So, it is a opening symbol, and so it has to be pushed onto stack. Then we encounter a 4, it can be skipped, and then we encounter a closed bracket, closed square bracket. So, we will be popping one of the entries from the stack. So, now you know always the top pointer would be at the topmost symbol in the stack. So, as in this case a square bracket had been our topmost symbol, and so it would be popped. So, we will check for a match whether both of them are square brackets, and one is the opening and other one is the closing. So, if the things match, then we can pop this entry out of the stack and proceed with scanning the rest of the input. So, in our case the next input is a closing bracket. So, then we have to look at the topmost symbol in the stack. It is a opening bracket. So, we have to pop, and these two symbols match. So, we pop it out and proceed with reading the rest of the symbols in the input. And so, then we encounter a star 3 comma D plus F. So, all these we will ignore, and then we again encounter a open bracket. So, we push on to stack, 5 will be ignored. Then we encounter a closed bracket. So, we will be popping an entry from the stack, and once we have the last symbol from the input, which is closing braces, that should be the bottommost element of the stack. So, it will be popped, looked for a match, and so we stop saying that the symbols are balanced. If in case the symbols are the brackets are unbalanced, if there is an imbalance in the brackets, then that we will be reporting an error that the symbols in the expression, that is the parentheses in the expression, are not balanced. Now, we move on to the second application of stack. Here we see how to convert an expression in infix form to a postfix form. So, we should be knowing by this time what an infix expression is. An infix expression is one in which the operator lies in between the operands. For instance, if I say A plus B, here you could see the operands are A and B, and the operator plus lies in between the operands. So, the general way of we writing the expressions is in infix notation, but our computer processes expression in postfix form. So, in order for the computer to process any expression, first of all the expression which we have written in infix form should be converted to postfix notation. And for converting the expression from infix to postfix, we will be using a stack. So, these are some of the facts for converting an expression in infix form to postfix form. And whenever we do this conversion, that is when we convert from infix to postfix, the operands will always stay in the same order with respect to one another. Say whatever order the operands appear in the infix notation, it would be the same order the operands would appear in the postfix notation as well. Only the difference lies with the operators. I told you that with infix expression, the operators lie in between operands, right? Whereas in case of postfix notation, the operators would be moved out of operands. So, that is if the expression we consider to be in infix is A plus B, then the corresponding postfix expression would be A B plus, that is the operator would follow operands, and all parentheses would be removed when we convert an expression in infix to postfix. So, here I have presented to simplify or to better understand how infix expression could be converted into a postfix notation manually. So, here let us consider this example. We have an expression 3 plus 4 star 5, and we know very well from the operator precedence that star has more precedence over plus. So, we just emphasize the order in which this expression has to be evaluated with the help of parenthesis. We know that parenthesis has the topmost priority, and if in case we include a parenthesis in our expression, then we know very well that that portion of expression will be evaluated first. And if we have multiple parentheses in an expression, always the innermost brackets have the topmost priority, and that is that sub expression will be the one that is evaluated first. So, here the given expression 3 plus 4 star 5, I have just added parentheses to decide the order in which this expression has to be evaluated first. So, according to operator precedence, star has topmost priority. So, 4 star 5 has to be evaluated first, followed by that the result has to be summed up with 3. So, this is how this expression has to be evaluated, and accordingly we have marked the brackets. In order to convert this expression into a postfix notation, you have to move the operator towards the closing symbol, closing brackets. So, whatever operator that lies between any brackets, that has to be moved towards its closing bracket. So, star has to be moved towards the closing bracket, that is after 5. Plus has to be moved towards its closing bracket, that is after star, right. So, this is how this expression would be converted to postfix. So, the result would be like 3, 4, 5 star and plus. So, this is the equivalent postfix notation for the given expression. Similarly, we have one more example where we have slash, cap, minus, star, etc. So, we could see many occurrences of minus here, star here, and you know that if star appears twice in an expression, then we will be giving preference from left to right. So, whichever star appears first from left to right, that would be evaluated first. So, accordingly we have marked the brackets for this expression, and you know cap has the highest priority here or the precedence here, and so that would be the one that gets evaluated first, right. So, we have marked the we have marked we have put brackets here according to the precedence, and you could see the associated postfix notation for this given infix expression. So, here I have given you some more examples for converting an infix expression into a postfix notation. So, the first one is the very basic example which I told you before. So, here in the second example you could see we have plus and star, and you know star has more precedence than plus. So, that has to be evaluated first. So, if we had done this manually, then we would have put brackets for brackets to denote that this has to be done first, followed by a plus b star c, right. So, this is the equivalent postfix notation. Likewise, I have given you some more examples. Of course, you could try both manual as well as implementation, which we will be learning in the next slide, how to convert infix to postfix, and check whether you are getting the associated results. So, here I have presented the procedure to convert an infix expression into a postfix one. As I was mentioning before, when we convert an expression in infix form to a postfix one, then operands would be in the same order, only the operators position would change. So, operators which had been appearing between the operands would be moved towards the end. That is what we mean as a postfix expression. So, here in this case, in order to convert from infix to postfix, we will be using a stack, and we will be pushing the operators and the symbols onto the stack depending upon the condition. So, whenever we encounter a open bracket, we will be pushing all the symbols. By symbols I mean the either open bracket or square bracket, whatever it is. So, we will be pushing all the symbols onto the stack till we encounter a closing bracket. So, whenever we encounter a open bracket in our expression, we will be pushing the open bracket and all the operators following it till we encounter a close bracket. So, this is the first rule we will be adopting in order to convert an expression into infix to postfix. And if in case we don't have any open or close bracket, but we just have some operators alone in the stack, in that case we will be scanning the input, and if we encounter an operator in the input, and we are having an operator in the stack as well. So, we will be checking the operator that is being pointed to by top, which is the topmost element in the stack. So, we will be checking, we will be comparing the precedence of the operator that is on the top of stack with the one that is available in the input now. So, if the operator in the input's precedence is more than the operator at the top of stack, then we can very well push the input operand into the stack. If in case the operand in the input's precedence is less than the operand at the top of stack's precedence, then in that case we will be popping the operator out of stack and pushing the input operand into the stack. So, this is the rule which we will be following in order to convert an expression in infix notation to postfix notation. So, I will be explaining you with an example so that you will be better understanding the concepts. So, the algorithm goes this way. If we encounter an operand, we will be just placing the operand into the output. If we encounter a left parenthesis, then we have to push that onto stack. So, when we encounter a closing symbol, then we have to pop entries out of the stack till we encounter a opening symbol. And if suppose we have some operands with us, then we have to check the priority of the operands. As I said before, if the input operand's precedence is more, then we can push the input operand. If the input operator's precedence is more, then we can push the input operator onto the stack. If the input operator's precedence is less than the one that is at the top of the stack, then we have to pop the operator that is at the top of stack and then push the input operator into the stack. So, we will be seeing how to do this with an example, and we have to ensure that if we can stop this procedure only when the stack becomes empty. Till then we will be reading the input and do the necessary processing. So, let us consider an example here. So, we have here with us an input expression a minus b plus c star d slash e, and we want to convert this infix expression into a postfix one. So, let us consider we process one symbol at a time from the input expression. Our first symbol is a, it is an operand, so we straight away place a in output. Next symbol is a minus, it is an operator, so we just push that operator onto stack. Next, what we encounter is an open bracket. So, whenever we encounter a open bracket, we straight away push it onto stack. Then we encounter b, which is an operand. Whenever we encounter operand, we straight away place it onto output. Then we encounter the next symbol, which is plus. Plus is an operator. Already we have encountered a open bracket. I told you already, whenever we have encountered a open bracket, we need to push all the operators till we encounter a closed bracket. So, we push plus also inside the stack. So, now plus is at the top of stack. Then we have c, it is an operand, so straight away place it in output. Then we have star, it is an operator, so I am just putting it on top of plus. So, now star becomes the top of stack. Then we encounter d, so d becomes d is an operand, so we place it straight away in output. Then we have a closing symbol. So, as I said before, whenever we encounter a closing symbol, we need to pop all entries out of stack till we have a open bracket. So, we have star and plus within, so that will be popped out. So, that is why you see star and plus in the output now, and we have encountered the closed bracket, and after that we have two more symbols left with the input. One is a slash, so it is an operator, and so we straight away push it onto stack. Then we encounter e, which is an operand, so place it in output. After that we have reached the end of input. Once we have reached the end of input, we may have to just pop out all the entries in the stack till it becomes empty. Thereby we pop slash first followed by minus, and so this is the corresponding postfix expression for the given infix expression. I have one more example for us to better understand the infix to postfix conversion. Here the expression is very simple. We have 7 minus 5 star 9 slash 2. So, this is the order in which we are going to scan the input, that is we are scanning the input from left to right. We encounter open bracket, so put it onto stack. We encounter 7 operand, so place it in output. Minus is an operator, push it onto stack. we encounter 5, it is an operand, place it in the output. Then we encounter a closing bracket, and so when we encounter closing bracket, as I said before, I have to pop everything till open bracket. So, I pop minus, so that becomes that appears in our output. After that, we have a star, we push that onto stack, then a open bracket, push that also onto stack. A 9, so 9 is an operand, place it in the output. Slash we have, it is an operator, so push it onto stack. Then a 2, so it has to be placed in the output. Then we have a closing bracket. As I said before, when we encounter a closing bracket, we have to pop everything till open bracket. So, till open bracket we have slash alone, and that is popped out. And after that, we have reached the end of expression. So, now we have to empty the stack. So, the stack now contains only star, and that will be popped out, and that marks the end of the postfix expression. So, this is how we convert whatever infix expression we give. This is the procedure we adopt to convert it into a postfix notation. And now we are going to study how we are to resolve, or how we are going to evaluate a postfix expression using a stack. And I was telling you before the difference between infix and postfix expression. So, in an infix expression, an operator would appear in between the operands, and in a postfix expression, I was telling you that operator would appear at the end. And we have one more notation called as prefix notation, in which the operator would appear first and operands would be following the operator. So, if we have such a notation, we call it as a prefix notation. So, we call a prefix notation as a Polish notation, and a postfix notation is also called as a reverse Polish notation. In some of the books, you might be noticing that instead of postfix notation, they would be mentioning it as reverse Polish notation, but they both mean the same. So, here I have shown with an example an infix expression and how the equivalent prefix and postfix expression would be there. So, here in this case I have 2 star 3 plus 4. So, I have marked the brackets in such a way that 2 star 3 is evaluated first, followed by summing up of 4. So, if this is the case, as you know very well how to convert an infix into a postfix notation. So, star would appear after 3 and 4 plus would appear after 4. So, this would be our equivalent postfix expression. And in other words, if suppose I want the evaluation to happen this way, that is 2 star 3 plus 4. So, that is 3 plus 4 has to be summed up first, and then the result has to be multiplied with 2. That is also can be done if we fix if we mark parenthesis in this way. If this is the case, then the result would vary. You could see the resultant postfix expression would be different. So, as if we have not mentioned any brackets in our expression, then the expression would be evaluated based on the standard operator precedence. So, we will be fixing priorities for the operands based on the standard operator precedence. Or in case if you want to do some computation before something else, in that case we can fix priority or preference of some computation over the other by marking some brackets in the expression. But the results would be varying. The corresponding postfix expression would also vary depending upon the order in which we evaluate the expression. So, this is the algorithm for converting or evaluating a postfix expression. I was mentioning before that we normally write expressions in infix form, whereas your computers want the expression to be in postfix form, and only if it is in postfix form the corresponding expression can be evaluated employing stacks. This algorithm tells us how to evaluate a postfix expression employing a stack. So, for evaluating a postfix expression, first of all you should have a stack ready and initialize the stack to be empty, and then we will be reading an item from the input. So, if it is an operand, we will be pushing on to stack, and whenever we encounter an operator, we will be popping entries from stack. So, mostly the operators would be binary, and so we may have to pop 2 entries from stack, perform the necessary operation, and finally we have to push the result back onto stack. So, we will be keeping on doing this till we reach the end of input symbol. So, let us consider the given expression. So, we have been given with the postfix expression 2, 3, 4 plus and star. Let us see how to evaluate this postfix expression using stack. So, first symbol which we encounter from the input is 2. We are scanning the input from left to right. So, the first input is 2, it is an operand. So, we push it onto stack. Next symbol is 3, it is an operand. So, we push it onto stack. The next symbol is 4, it is also an operand. So, we push it onto stack. The next is an operator plus. So, I said whenever we have an operator, we have to pop 2 entries from stack. So, we pop the first entry. Now, you know 4 should be at the top of stack because that was the one that entered into the stack last. So, that will become our second argument. Then we pop one more element from the stack, that should be our 3, that becomes argument 1. So, now we perform the corresponding operation with these 2 operands. So, the operator is plus here. So, we sum up 4 plus 3, that is 7, and finally, we have to push the result back to stack. So, 7 will be pushed onto stack. So, at this moment your stack will be containing just 2 entries, one, the bottommost element should be 2, and on top of it we will have the result 7. Then we encounter the next input from the next symbol from the input, which is an operator star. So, it is an operator. So, we have to pop 2 entries from stack. So, 7 becomes our second operand and that is popped out, and 2 becomes the first operand, it will be popped out, and we perform the desired operation. Here in case we have to do a star, that is multiplication. We compute 7 into 2, which is 14, and the result is pushed back onto stack. So, now the stack contains the result of evaluating the postfix expression, which is 14, and finally, once we have reached the end of input, now we can pop 14 to be the result of evaluating the given postfix expression. So, I have shown the same with some more examples. So, here we have a stack, we have one input symbol which is an operand, which is 6. So, we push it onto stack. Then we encounter one more input symbol which is 3. So, we push it onto stack. Then we have an operator as input. So, here the operator which we have encountered is a plus. So, we pop 2 entries from stack. So, 6 and 3 have been popped out. We perform operation addition between 6 and 3 and the result is 9, which is pushed onto stack, and the result is there. Now, we have the rest of the input to be processed. Now, we have a 2, it is an operand. So, we push it onto stack. Then we encounter one more operator which is star. So, when we encounter a star, then what we have to do is we have to pop 2 entries from stack, that is we will be popping out 2 and 9, performing a multiplication of 9 and 2, and the result is 18, and that will be pushed onto stack. So, once we have reached the end of input, as I said before, we have to pop the entries from stack which is left out, which is the result of computation, that is 18 would be popped out as the result of evaluating the given postfix expression. And here I have given one more example. We have the given postfix expression 7 5 minus 9 2 slash star. So, we have placed it for processing. So, 7 and 5 they are operands. So, they are pushed onto stack one after the other. When we encounter minus, we pop both of them and perform the operation. So, the result is 2, which is pushed in. We have 9 and 2 as 2 other inputs, as they are operands, we are just pushing onto stack. Then we have a slash which is an operator, and so we pop 2 entries out which are 9 and 2, perform a slash between them. So, the result is 4.5, which is pushed onto stack. And finally, we have one more operator as input symbol, and so we pop the other left out entries in stack which are 2 and 4.5, perform a multiplication between them and store the result back to stack, which is 9. and that is the end of input expression. So, our result of processing this postfix expression is 9. So, the same has been presented in the form of an algorithm. So, initially we have a stack, we will be repeating the procedure till we have more we are left out with more symbols in the input. So, we read a character, if it is a character we can straight away place it in the output. So, we have one more loop. So, we are going to loop till we reach the end of input. Here we have used an equal to mark the end of expression. We check whether the input read is a number or whether it is an operand or an operator. So, if it is an operand, we read a number, output the number and push the number onto the stack. Whenever we have an operand, it has to be pushed onto stack. Otherwise, if it is an operator, then we will be popping out the 2 entries from stack, performing the operation and push the result back to stack. So, we will be repeating this procedure till we reach the end of input. In between, if we encounter any other symbol other than operator and operand, we may report an error. So, that is how this algorithm works. To summarize what we have seen so far, we have seen the usage of stacks for 3 other applications. One with respect to balancing the parentheses in an expression, and we saw that whenever we have an opening symbol we will be pushing on to stack. When we encounter a closing symbol, we do pop and check whether the symbols match. So, that is how we used stack for balancing parentheses. Then we studied how to convert an expression in infix to postfix using stack, and we saw the corresponding algorithm for doing the same. And at last we studied how to convert or how to evaluate a postfix expression employing a stack. So, we learned that when we have operands, we have to push it onto stack. When we encounter operators, we have to pop the entries from stack and perform the necessary or desired operation. And apart from that, we can also use stacks for handling recursion, which we learned with the previous lectures. And not only that, whenever in any programming language the compilers make use of stacks for handling functions as well as for handling recursive functions. And we learned with the previous lecture that whenever we have functions, there would be necessary activation records which are pushed onto stack, and when we return from a function, the corresponding activation records are being popped out of stack. So, for all these cases, we have seen how stacks are getting used, and it is one of the widely used data structures behind many concepts in the world of computer science. And now to better explore how infix expressions can be converted to postfix, I have given you some example problems, and of course you could try this on your own. And to test our understanding, I have given you one question where I have given you a postfix expression, and I have asked you what it would evaluate to. So, we are given with the expression 632 plus star. So, this is a postfix expression, and you know how to handle it. So, first 3 are operands, so we will be pushing it onto stack, and when we encounter a plus, we have to pop 2 elements from stack and do the operation. So, we will be doing 3 plus 2, which is 5, push the result onto stack back, and then we encounter a star where we pop 2 entries from stack which are 6 and 5, we do a multiplication, the answer would be 30. So, this is how we convert an expression from, we will evaluate a postfix expression. I hope you have better understood how stacks are employed for each of these cases, and thank you for watching.